Join us for Reimagine Buildings 25, our global online conference this June 12th, or June 13th if you're in New Zealand, Australia, or Asia. This isn't just another event. It's a global gathering of the people building what's next. We're bringing together the doers, the visionaries, and the quietly revolutionary, those who are ahead of the curve in retrofits, new construction, and the future of low-embodied carbon materials and climate-positive building systems, past, present, future. From real-world retrofit wins to high-performance new builds to the boldest ideas in next-gen materials, it's all here, one place, one time. And you won't just watch it happen, you'll be part of it as you connect with others on the same path. Show up, be inspired, and leave with clarity, momentum, and a community that has your back. Register for Reimagine Buildings 25 today, the conference where we reimagine what's possible and level up to build a future where we can thrive. Visit PassiveHouseAccelerator.com for more.
The toxic reduction and greenhouse gas reduction, carbon reduction in the building industry are completely intertwined.
It is such an amazing thing to renovate, to reuse a building, to put a building into the world. There's so much opportunity and optimism that comes with that process, but we have to do it for good.
Hello and welcome to the Reimagine Edit, a special series of the Passive House podcast that shares curated insights from our experts and residents at the Reimagine Buildings Collective, our membership community that brings together builders, designers, and changemakers driven to create healthy, climate-ready buildings so that we can share hard-won lessons, level up our practices, and build the networks we need to thrive. Today is June 7th, 2025, and in this episode, we'll hear selected clips from Ed May, Nakita Reed, Tessa Bradley, Bev Craig, Mike Steffen, Lisa White, Jonsara Ruth, and Alison Mears. I must say, it's quite a group. I'm Zack Semke, Director of Passive House Accelerator and host of the Reimagine Buildings Collective, and a big thank you to you for tuning in. Okay, let's dive right in. Let's start with Ed May. He's principal at bldgtyp. He's the instructor of the collective's PHPP course and Honeybee PH course, and he's a community favorite at our Ask Me Anything events. In this clip, collective member Eric Zeiss asks Ed for guidance on retrofits.
The stages of retrofits in particular. Where do you go and where do you stop?
It's hard, isn't it? It's really hard.
It's sort of a continuum between doing almost nothing and tearing the house apart and rebuilding.
Yeah. So the problem with retrofits is that they're always so bespoke because they're always so contingent upon what needs to be done to that building. Oh, this building's roof failed, so obviously we have to do the roof. That's not like a general rule for retrofits. Like you wouldn't say like every retrofit has to redo the roof immediately. But this one, the roof failed, and so we have to replace the roof. So that's always part of it. So the retrofits are really hard to come up with a global set of requirements. It's always so particular to the individual construction. That said, there's like a couple of physics-based things that you want to be really careful of when thinking about phasing your retrofits. The primary one being that you don't want to increase the airtightness of the building significantly without considering the ventilation. Right? So you really don't want to get yourself in a scenario where you've made the building more airtight, you're trapping a bunch of moisture in the building, but you haven't upgraded the ventilation system in order to deal with that moisture. Or maybe you haven't upgraded some of the component areas, walls, roofs, floors, far enough that they won't have condensation issues. So if you make an airtight building, but you have an uninsulated wall and higher relative humidity, no ventilation, right? This is a recipe for the problems that we saw in the first generation of retrofits in the 90s, I guess, let's say. And so you really have to be cognizant of that and careful about that. Now, that's not like a prescription for how to do it. That's just a thing to say, like, these are like the things you need to worry about are increased relative humidity and cold surfaces, condensation, and ventilation. And you always have to kind of keep that in mind when you're considering like what are the appropriate strategies to apply to any individual building. But I think fundamentally you would start with an assessment of what are the needs of the building. So that's like an easy one where you say like, okay, well, these 5 things failed, so those 5 things have to be replaced right away. And then given that context, how do we choose amongst these other things to prioritize? Personally, I really put the ventilation up towards the top of any list. I mean, I think that the ventilation is not the most meaningful and impactful thing when it comes to energy performance, but it's the most important thing for health, comfort, durability of the building long term. And then you get into questions of, so for instance, here in the United States, we typically have these double hung windows that slide. And in many parts of the world, or not the world, this country, the way that we provide cooling is by putting an air conditioner in the lower part of those windows. If you were to swap out those windows for casement windows, tilt turn windows, and you can no longer put a window air conditioning in, and you didn't build like a proper heat pump cooling system for the building, now you've really made people's lives much worse. So yeah, you've upgraded the windows, but you've made their living situation much worse because they no longer have cooling now. So these things are really hard to disentangle. They're really hard to pull apart. They really work together as a whole system. I mean, that's part of the whole shtick of the passive house thing is like these 5 fundamental principles work together as a system. You can't do it without all 5 of them. That's like kind of the whole idea. And so then, yes, when you get into retrofits where you're like, well, which of the 5 do we do? And you're like, no, the whole point was you do all 5 of them because all 5 of them reinforce one another. But of course, the reality is that you do have to prioritize and you have to sort of pick and choose amongst them.
Next up, I've got a clip from Nakita Reed's AMA session in the collective. Nakita is an award-winning architect at Quinn Evans and is host of the excellent Tangible Remnants podcast that you should definitely check out if you haven't already. Here, collective member Mike Wong asks Nakita how she pitches Passive House to funders and builders.
What is the first sentence of your pitch to 1, funding stakeholders who are not familiar with Passive House, and 2, to contractors and subcontractors who are not familiar with Passive House?
So after I understand if the developer is going to be a long-term owner of the building or if they're just trying to flip it. If they're going to be a long-term owner of the building, then typically I confirm that they are interested in saving money on the operational costs and then pitching it in a way of helping them understand what the ROI would be. There are some times when they like to think, oh, it's going to be 10% more expensive or whatever kind of arbitrary number they have in their mind of how much more expensive it would be to do a green building. But thankfully in Maryland and kind of where we are, our building code is actually pretty well advanced and it's getting closer to the higher efficiency buildings than other parts of the country. So at this point, we're able to make the case that it's really not that much more expensive to do a high-performing building than just a code-based building because of where the codes are in Maryland. Yeah. So a lot of times it's helping them understand that the delta between doing a high-performing building is not going to be that great, and also helping them understand they're going to save money in the long run. So that's one part of it. The second piece of it in terms of talking to the builders, because that is a struggle sometimes, particularly builders who have been in the industry for a long time. They've been doing something the same way for a number of decades, and they don't want to have to air seal a certain way because they're like, no, I've been doing it this way. It's fine. It's always been fine. Us being able to communicate to them that actually, no, we're going after a certification, which is going to require more verification. We need to pass a blower door test. We need to pass certain regulations that if you build it this way, you will save yourself pain in the long run. Because if you build it the way you've always built it and we fail that blower door test, you're going to have to fix it later. So it's like helping them understand what's in it for them, even from a labor standpoint. And also making sure that the conversation with the builder is one of respect and not condescension. Because I think sometimes architects come in trying to be like, oh, you've been doing it wrong and this is a better way to do it. And the contractors often look at them like, you don't know how to build things. What are you talking about? So it's kind of walking that line and having that conversation from a mutual respect of like, hey, we're on the same team, but here's what we're trying to go forward. And I have to do that also with historic buildings, because there are some contractors who haven't done historic work and they don't understand, well, why is this historic? What does this mean? And there's one contractor I was working with on a project at the VA. It was just a historic mill. And he was like, well, what's so historic about this building? Who was president when this thing was built? It was a mill from the late 1700s. And I was like, we had a king. Like, there was no president at that time. And that's why this building is important. And we need to actually make sure we do it correctly.
Our next clip comes from our inaugural Reimagine design interview, which is part of our Reimagine Tuesdays fireside chats hosted by Michael Ingwe, founder of Passive House Accelerator. In this first interview, Michael sat down with the inimitable Tessa Bradley, principal of Artisans Group. Michael kicked off the conversation by asking Tessa how she fuses great design with Passive House.
The challenge, I think, is making a project beautiful and unique when you have the same Passive House challenges on every project. So, for me, I feel like there's the same things that come up, and I'm coming up with different ways to handle them each time. Like, in my climate, I usually, and the way that, some of our design philosophies, we end up using a lot of glass, which, many smart people would say we're overglazed, to which I would say yes. And so, we oftentimes end up with thick assemblies to make that decision on particular projects. And so, I'm constantly dealing with like a Nicole Kidman sized forehead on all of my projects, right? And so, like, if I'm solving that with like angled overhangs or another roof that cuts into it, or, this particular, that particular, I feel like we've solved it 1,000 times and there's still more ways to solve it, right? So I feel like sometimes the problems are really similar, but like our creativity around the solutions is still churning. And then, I've done some Passive House basics, like how to design your first Passive House classes. And my rule of thumb is don't be an asshole, very famously, to yourself or the project, in that make one dramatic move with your design and otherwise attempt to keep it simple, because it will be complicated enough. So for me, that's oftentimes, a move of glass or a really defined profile or a really strong language with color or, some kind of sculptural form, whatever, the language or the hook or the partie of the design is, have that sort of be the focus. And unless you have a project with a really big budget, don't just overlay complexity on top of it. You have a whole career to use all of your ideas. You don't have to use them all on one project. And then I love that you said, what opportunities does Passive House create for you? I've been thinking a lot about this because I did a keynote for a green expo recently for businesses. And when I looked at how we had built our firm, this pattern really emerged that I hadn't maybe even coalesced into a singular idea for me yet. And that was, we did our first Passive House and we used that to sell more. So then we were doing more of them. Well, then we got better at it. Well, and then there was a market for them because people loved them and we built a bunch because people had been in them and word was out. And so we kind of have this history of making a market and then serving that market, right? And it's a way to be a niche, so you're not just competing on price. It's a way to stand out, and do something measurably better. I feel like there's a lot of lanes in architecture, and there's like the big, expressive, really irresponsible lane of architecture that is not good, not objectively good, right? It's only pretty. And then you have the lane of so sciencey that maybe doesn't feel like art, right? And it's not soulful to live in. And so, by choosing to sort of pick our lane, I feel like we just kept building a market and then serving that market over and over. And we did it at several scales. We've applied our capacity for sustainability and our attention to that on master planning now, and really large, incredible, like tribal projects for some of our local tribes that are providing incredible, services to their community and things like that. So, it started with high performance, but learning to solve that design problem, turns out that your business is just full of design problems. And so we've seen that be, now we're doing our new office, our new Passive House mixed use building. And so we're showing the developers we've been working with for years that here's yet another market that we can serve and we're experts in. So it's kind of like you're making the rules of your own game.
Now let's pivot to the AMA and the collective with Bev Craig, one of the program directors of the Massachusetts Clean Energy Center's High Performance Buildings team, and a driving force behind the remarkable building decarbonization policy success in that state. In this clip, collective member Brent Watanabe asks Bev about how to address the upfront cost premium of Passive House.
So the demonstration that I was involved with here, we funded 8 multifamily projects to upgrade to Passive House. And basically on average, it was like about a 2.5% premium. So that included like the architect's time, whether it's Cascadia clips, better windows. Honestly, the biggest impact on cost was better ventilation compared to our code. I don't know that premium is going to be true in every state, right? It depends what your base code is. And I don't think you really know till you can do like a demonstration. I don't think it's, even in the multifamily space, it's ever zero. Sure. However, now that we are scaling here in Massachusetts, like in some ways it's more expensive and in others it's less. So it's more expensive because the people who know, let me step back. For that incremental cost, it was very clear that the architects and general contractors and verifiers and CPHCs or the PHI equivalent, the more educated and experienced they were, the lower the premium was. So like there's this issue, and I think you saw this in LEED, right? Like the early days of LEED, they always said, oh, it's a 2.5% premium. Then it just became paperwork, right? Like it's not really, at some point people understand it and internalize it, and it's not that expensive. So I think there'll always be some things like the window or the ventilation thing where there is like a material difference that's going to be more expensive, but there's also a whole bunch of things you can do on design side that can reduce cost. That premium discussion is great for like starting out because a lot of people think the premium's way higher than it is. But then I think the next iteration is, and this is going to be coming out of Passive House, Massachusetts, and I think you saw it. Did you go to the Phius Pro Forum?
I did, yeah.
Did you hear Walsh Construction talking about like how do we reduce the cost in general?
Yeah.
So like we're seeing the same kind of thing. We have to bring the cost of housing down. And so like it's big design things. It's lean construction. It's the difficult parts of Passive House, like learning how to do it, learning how to do ventilation, semi-central, like our central ones have always been a problem. Like there's like things we've learned, right?
Yeah.
Like how do we skip past the hard stuff so that the new teams don't have to learn it themselves? Because then you can bring the whole cost down. I would say like another thing that's very much like Walsh Construction, Bunker Hill in Boston, which is Passive House Mass just hosted them last month, and I can drop that webinar in. Basically, they're building 16 buildings at half the time and 20% less costs than they would typically. And they're all Passive House, so they don't mention that because like it's code now here, right? Like, so that's not the issue, but it's a very prefab focus, right? It's a offsite construction for the panels. They did CLT for the floors and ceilings, no subsurface construction. Even the stairwells were prefab offsite. So it's like the focus is fast and it's bringing down cost. But like that's how we get past this premium discussion, right? Is to like more into the innovation of how we make everything less expensive and you just assume it's really high performance.
Little did Bev know when she cited Walsh Construction's leadership in bringing down costs, but the very next Tuesday in the collective, we had Mike Steffen of Walsh Construction on for the inaugural edition of Reimagine Construction, also part of the Reimagine Tuesdays fireside chats with Michael Ingui that I mentioned earlier. Here's Michael kicking off that conversation.
Maybe just talk us through your cost-efficient design and construction methodology, how it's helped you deliver high-performance buildings on tight budgets and in contexts that you had to. Maybe just talk about that a little bit first as we kind of get into this.
Yeah, it's, going back 6 or 7 years now, we've kind of been working on this approach that we've come to call cost-efficient design and construction, or CEDC for short. It's really applying cost efficiency principles to the overall design of buildings and then down into the subsystems, utilizing standardization, repetition, prefabrication, where it makes sense and can add value, utilizing economies of scale whenever that's possible. But really a push towards more standardization. And I think everybody fundamentally understands what the potential benefit of that is. But where I really come down is that ultimately what we need is optimization. And until you get to standardization, until you get to sort of a fixed target with an element of design, you can't really optimize. You're always starting over from scratch. Everything is bespoke and it remains bespoke because you can't optimize it, because you never stop and take this one thing and build it once, build it twice. Every time you reiterate, you improve it and further optimize it, you tweak it. And that's the process that we really need to do, but we don't do as an industry. There's a key concept from lean construction, or really more broadly lean production, which is this notion of reducing variation. Reducing variation is the way to minimize waste, reduce mistakes and such in any production process. And we can think of that clearly as a factor in how we go about designing buildings first, but then also building them. And within CEDC, there's been a ton of focus on the unit plans as the basic building blocks of the housing that we're making. If we can standardize those unit plans, then optimize them, tweak them to make them better every time we go, just a little better. Then we've got like a great building block or widget to build our optimized and efficient buildings out of. We kind of characterized it in this idea of this 80-20 rule. We're not building the same building everywhere. We're not going to build a repetitive building anywhere. But the idea is to take the elements of the building and standardize as much of the building as you can, roughly 80%. And that is the unit plans and the exit stair enclosures and the elevator shafts and the windows and the kitchen layouts and the cabinets and such. But the 20% recognizes the fact that every site's unique, every context is unique, every program's unique. And so there is always going to be a need for customization. That's what really gives the building its character, how it relates to its context and site, how it becomes a good neighbor, and even the expression of the building, interior and exterior, how that's developed. We account for that in our idea of leveraging more standardization. We just want to see kind of less of that, but just in the stuff that really matters, the stuff that's apparent. And the 80% is all the stuff behind the drywall, behind the paint. Let that all be standardized and optimized as much as possible. And last thing I would say is, the goal is to find a way to achieve better buildings, but to do it at lower cost. But we're not doing it just to reduce costs. We're doing it to create room in the budgets. And these are limited budgets in affordable housing. Create room in those budgets. How can we get it on the order of 10 to 20% cost savings in just the base design of the building? And if we can generate that, especially if we can get up to like a 20% savings from what the norm is and what we're producing right now, we've really created room for incorporating all those value-adding performance measures, upgrading the finishes for, perhaps for aesthetic reasons, but really for durability reasons, both on the outside and the inside of the building, and to be able to include programmatic amenity spaces that are really helpful in some of these buildings, especially like the supportive housing buildings that we're involved with a lot. So we found that with a really disciplined approach to cost efficiency, it's a different idea, cost efficiency, different idea than energy efficiency, which we all put a ton of focus on. But if we really focus on the cost efficiency with discipline, we can make these things work, and we can actually pull the better buildings off, even in the affordable housing context.
Later that same week, we were honored to have Lisa White, co-executive director of Phius, join us for an AMA Friday in the collective. In this clip, Lisa describes Phius's innovative new retrofit standard, Revive, and its focus on passive resilience and total carbon reduction.
Maybe in 21 or 22, we set out to develop a new retrofit standard that was way more holistic. Graham Wright, our senior scientist, really led this effort with more on the Revive team, but this was really his initial concept. If we're going to retrofit buildings, we need to think about every material that goes into them from a carbon and cost perspective, and how that impacts carbon and costs along the way, like what you save over time, how that impacts the grid, like thinking about all of these things. So not just operational carbon, which is typically what we would think about with new construction, but also thinking about all the materials and all the maintenance over time. Alongside that, we needed to be sure that every material and the amount of material we're putting into the building is intentional and is it achieving a goal. And the question is like, what is that goal? With new construction, it was optimizing to reduce energy costs to save money over time. We knew we could add insulation, save energy, save money. And there's, you know, there's that like sweet spot where it made sense. With retrofits, we didn't necessarily think it was the same case. So with retrofits, we set out to determine what level we needed to invest in the enclosure in order to ensure resilience for the project. And resilience meant outage resilience. So over a certain outage period, I believe we use 5 days winter, 5 days summer, like worst case conditions. Can the building stay habitable and not have pipes freeze? And people can live there, breathe there. And we found this to be really important as we believe there will be more natural disasters, more grid outages, all of that as our climate changes and as our grid changes. And we've already kind of seen that. So we leaned into the resilience angle for the enclosure part of it, and then a cost metric for like the total energy / carbon combination for what the building can consume. And we formed a standard around that. Essentially, you start with your existing building, and it's very different from our new construction program because there's an audit phase of your existing building. And then you think about your project requirements, like the owner's project requirements, what are your goals? And then essentially map out like a phased retrofit plan. And the order in which things happen is obviously important in terms of carbon impact, cost impact. If you start by just electrifying, for example, you're going to need a bigger mechanical system than if you start with the enclosure and then put the mechanical system in later. So the order matters, and that's something that our tool assesses. But essentially, you look at what's your end goal and then map out how that can happen. It can happen all at once, or we allow it to be a phased retrofit. You look at your building and figure out where you want to go, and that where you want to go needs to meet that resilience metric in terms of the enclosure. And then it needs to be a total cost metric lower than where you're at right now. So compliance with this standard, the revised standard, uses a completely different tool than we use for new construction because it's a completely different simulation. It's simulating outages for resilience, and it's calculating this total cost. So it's called the Revive Calc tool, simple, Revive Calc. And I will say a lot of these next few years is going to be focused on getting this tool a little more market ready. We've had great internal resources and a few external that we've gotten to develop this, but it's definitely still in its young stages, I'll say. But our team is there to help you out if you submit a project through this program. I should mention one more thing, that it is focused not only on like outage resilience, but resilience thinking about flood zones, hurricanes, wildfires, all of that. We're trying to be, as Graham would say it, like a shield and a sword against climate change. So we're trying to cut down emissions, but we're also making sure these buildings are built to last. If you're going to put money into it and resources into it, making sure it's done the right way.
And this brings us to the inaugural edition of our Reimagine Materials series, also part of Reimagine Tuesdays. Michael interviewed Jonsara Ruth and Alison Mears, co-founders and leaders of Healthy Materials Lab at Parsons School of Design. In this first clip, Jonsara reminds us of an important truth.
You know, in this time of so many multiple crises, when we all, I don't know, I can't speak for everybody, but I know that in our smaller circle, everyone feels it, extreme weight. I think where the Healthy Materials Lab sees optimism is that as designers and architects and builders, we actually have agency to make a difference. And, you know, that is the underlying kind of fuel that fuels our lab, our design research lab and our team, which is if everybody knows a little bit more, we actually have the ability to steer things in the right direction. And where we all know that the practice of architecture and building is very, very difficult, complex, requires so much attention that it's hard to understand that we have so much agency, but we do. And I think we exist to help the industry, to help you all, to help our greater industry just do a little bit better so that the whole planet and people and living beings can do better. And I think that's what fuels us.
And here, Allison describes how the degradation of common building products as they age is creating a health crisis inside our buildings.
As buildings age, they degrade. And it's the same with the common building products that make up particularly our interiors. And we focus on interiors and insulation because those are the spaces where we're most exposed. We spend our time indoors. All of us here are indoors. We could be outdoors, but we're not. We're indoors. We spend 90% of our time indoors. And so this is our environment. This is our natural, artificial environment in which we live. And so as we occupy these spaces, these materials, the products that make up this space, degrade over time, and they shed particles. The particles can be connected to the dust in the room. They can fall as dust to the floor into that carpet, often called a toxic sink. They can be airborne. So we're exposed to them through inhalation. We can breathe them in. We can absorb some of those chemicals through our skin, through that dermal exposure. And if you have a child or a baby who's crawling on that toxic carpet, they can ingest them. We can ingest them too, but it's much more likely that it's a child who's ingesting them. And then those particles, I think there's a lot of understanding now about microplastics, about our exposure to microplastics through water or through air. These other chemicals are similarly part of that environment where we're being exposed to them and then they're being absorbed into our bodies. And our bodies take those materials in, and they're foreign bodies within it, and they're absorbed within our very being. And their relationship to and their interaction with our bodily functions are quite complex. But because they're foreign bodies, they act in a way that is different from the food that we eat or the air that we breathe, hopefully. And so things like, as we think of, for example, plasticizers in bisphenols and phthalates, plasticizers in your resilient floor or in your acrylic paint. Those particles are hormone disruptors. And what those chemicals do is they mimic our hormonal function. And so by mimicking them, your body thinks that they're also like a hormone and so start to disrupt the way that your hormones act within your body. Incredibly destructive and not something that we should be exposed to and detrimental to our health. And so if we can go through lists of chemicals and look at the particular impact of those chemicals in our body, but all of them are foreign to us. And I think that's the challenge, is really acknowledging that and that the problematic nature of the foreignness in our bodies.
Jonsara points out that the low-hanging fruit in terms of making indoor spaces healthier is kind of hiding in plain sight.
What are the places, just kind of common sense, like if you look around your room, what are the materials that make up the most surface area? We say, well, it's the walls, floors, ceiling. That's pretty much, we have in this room that I'm in, 5 of those surfaces, the walls and the ceiling are paint. And the floor, in this case, I'm standing in a room that has polyurethane on the floor and it has acrylic latex paint on the walls. Those are 2 categories. We thought, oh, you know what? We're going to spend the first year of our lab on paint. And the second year we'll spend on flooring. And 10 years later, we're still on paint and flooring because it is, we believe that if everybody were to change these 2 materials that we use so often, it would radically change the building industry. It would radically change the health of so many people, both in use and all the way through production. Paint is a binder, pigments, solvents, and additives. That's every paint is made up of that. In ancient time, 1,000 years ago, the binder could have been lime, a mineral, or it could have been an oil, like linseed oil, like a plant oil. The solvent might be water, for example. And then there's a pigment that, as people rub rocks together, there's a mineral, you make color and you put it together. And that's, I think we were talking before this about just lime paint in Italy. Now our binder is acrylic a resin, a kind of polymer that is made up of many things. The solvent is still water. There's a host of additives, which are antimicrobials. Maybe you see antimicrobials. You might see all kinds of chemical additives. If you look on the ingredients of paint, there's more than 26 ingredients that are all very hard to pronounce. And if you look at those chemicals, what we do, you don't have to do this because we do this for you, but we look at each of those ingredients and understand their chemical number and understand their associated health risk. And what we find is acrylic and latex paint are really not so good at all. And in fact, it's not just when they're wet, but after they dry and start to degrade, those additives come out into our air and they're microscopic. We don't see them, but we do breathe them in and ingest them. Now, there are alternatives. And this is what's really amazing about 2025. You can go out, even at mainstream stores now, you can buy lime-based paint. You can buy mineral paint that's based in potassium silicate. You can buy plant-based oiled paint, and they're just as easy to apply as an acrylic and latex. And a secret to the world is that like the big major producers, paint companies, are getting shaken at the core. We've had them come up to us at big exhibitions and say, would you ever show our paint, our low VOC? We say, nope. And now we start to see that they're starting to sell lime-based paints and they're starting to sell mineral-based paints themselves. So that could be a material that everyone could change today, tomorrow, and make radical change. If you look at the extraction again of like the whole life cycle of carbon emissions, say, that are involved in the making of paint, the embodied carbon of paint, it's pretty extraordinary. It's a pretty big contributor to our greenhouse gas emissions issue. So it goes hand in hand. And that's true with most of the things that we do, that the toxic reduction and greenhouse gas reduction, carbon reduction in the building industry are completely intertwined.
Michael then asked Allison what she'd want to impart to students and architects, what she wishes she knew when she started out.
I think we have to be hopeful, we have to be vigilant, and we have to use our practice for good. And architecture is an amazing profession. It is such an amazing thing to renovate, to reuse a building, to put a building into the world. There's so much opportunity and optimism that comes with that process. But we have to do it for good, and we really have to think about, that we're not putting anything new that is toxic into the world. And we have to be conscious that we're in a precarious situation right now, and everything we do impacts our precarity at this moment.
And you can get started on the 6 surfaces that surround you right now.
If we're looking at the interior, the 6 surfaces that is creating your interior. If we're looking behind you, you've got a wood ceiling, you've got the painted walls behind you, and then you're obviously standing on something that we start with there in terms of paint and whatever flooring that you're looking at. And if you can install better products on those 6 surfaces, then you've already created a better room. And then hopefully you're not bringing in too much other junk in there in your kitchen cabinets or countertop or your bathroom or your furniture with the flame retardants and the foam. If you have that, then that's a really good first step. And we typically say just choose a better paint. Just start there, and that already gets you along this road, and it feels like you're making some progress.
And these natural paints do quite well just painted over their acrylic stuff.
The potassium silicate, the mineral-based are really good at grabbing onto anything. And, the thing about some of these mineral-based paints and like the lime paint is, this is crazy, but it cures not by heat or oxygen, but by absorbing carbon from the atmosphere. That's how it cures. And so it recalcifies. There's this whole thing called the lime cycle. But it recalcifies, becomes limestone again. And it becomes limestone. It's in its becoming of limestone for like 800 years. Like it continues to absorb carbon for a very long time. So it gets harder and harder and harder over time and more durable rather than less, which is also a really interesting quality.
And I think that's a wrap. Thank you to Ed, Nakita, Tessa, Bev, Mike, Lisa, Jonsara, and Allison for sharing their insights with us over the past few weeks. As always, these clips just scratch the surface. So if anything piqued your interest here, please do dive into the full replays of these sessions available in the collective. And if you're not a member of Reimagine Buildings Collective, please join us. You'll get direct access to experts and peers on the same journey. You'll get to know them, ask your burning questions, and expand your mind and your practice by engaging with these thought leaders and fellow trailblazers. Head over to reimaginebuildings.com to learn more. We just published several member stories there, video messages recorded by our members for you. So head over to check those out. I hope you'll consider joining us. Speaking of joining the collective, a big welcome to our newest members, Mike Steffen, Paul Keeley, Lisa White, Srikanth Santhosh Kumar, Stanley Mena, and Jennifer Childs. With that, thank you for listening to this 8th episode of the Reimagine Edit, a production of the Passive House podcast by Passive House Accelerator. As always, don't hesitate to DM me with anything Reimagine Buildings Collective related, what you'd like to see on the platform, any ideas you'd like to share. We're building this community with you, so let us know. And don't forget to invite your friends and colleagues to join us. Thanks, and have a great couple of weeks. Be well.